Hello everyone, welcome again to my channel. In the last video, we discussed about hierarchical clustering algorithm. If you have not seen that video, then please have a look on that video and then continue with this video where we are going to learn one technique of hierarchical clustering algorithm. So we are going to solve one problem of this hierarchical clustering using single linkage. Okay. So we are using single linkage clustering. So how it works, we will look at through an example. Okay. So here we are having an example. So here you can see that there are 6 data points, 6 clusters are there and some corresponding distances are given. Okay, so it is a proximity matrix. Now we have to find out the Euclidean distance of these data points. So after making that, we will get a one distance metric. So let's have a look on that. Basically, first have a look on this formula of this Euclidean distance. How we are finding out the distance? So here square root of x minus a square plus y minus b square. Okay, so by using this formula, we are going to find out the distance matrix. So how we will? Let's have a look. So before moving with the calculation, we have drawn each data points on this graph. So here you can see P1, P2, P3, P4, P5, P6, all the data points are there on the XY plane. Okay. So using this matrix, we have drawn this visualization. Okay. Now, in the second step, we are going to find out the Euclidean distance. Okay, so Euclidean distance formula was square root of x minus a square plus y minus b square. So a and b are the data points. Okay, now let's have a look again on our matrix. So here you can see 0.40, 0.53, 0.22 and 0.38. Okay, so we are going to use these data points. Okay, so after having these data points, we will put those data points in this formula and we will find out the distance between P1 and P2. Okay, so after doing this calculation, we are getting the distance between the P1 and P2 data points, or you can say clusters, using Euclidean distance formula. Okay, let me show you the matrix once again. We are finding out the distance among P1 and P2. So here the distance is given like 0.40, 0.22 on x-axis for these data points, and on the y-axis it's 0.53 and 0.38. We are finding out the difference of these values, these distances, to find out the distance among P1 and P2. Let's move. We have find out the distance among these 2 points. Okay. Similarly, we will find out the distance of P1, P3, P1, P4, P1, P5 and P1, P6. Okay. So here we are having the distance on the x and y axis for the points P2 and P3. We will use those values and we will find out the distance among P2 and P3, and the distance is 0.15. Okay, let's move ahead, and here again we are finding out the distance between, that was for P2, P3. Okay, now we are finding out the distance of P3 to P4. Okay, so that's how we will keep in finding out these all distances until we get this kind of distance matrix. Okay, let me show you once again that matrix. Give me a minute. Okay, so we were talking about this distance matrix. So how did we get this distance matrix? So here again we will have a look like how we are finding out it. So you can see while finding out the distance among P5 to P6, we are using the distance given in this matrix. So here you can see P5 to P6. The value on the x is 0.08 minus 0.45 whole square plus 0.41 minus 0.30 whole square. Okay, so like this we will solve this formula and we are getting the distance among P5 to P6. After doing each calculation using Euclidean distance matrix, we are getting this kind of matrix where we are not requiring the values on the right side. We need all the left-sided values in this matrix, which are lying just left of this diagonal, where diagonal values are 0. Okay, we just need these values only. We don't need the right-sided values of the diagonals. Okay, so now we are ready with the distance matrix. Let's continue with the process. As we are going to use single linkage, so single linkage we need minimum distance among the data points. So you can see that the minimum value is lying here between P3 to P6, which is 0.11. Okay, so our first cluster would be P3 to P6. I'm repeating once again, single linkage is using minimum distance among the data points. Okay, so here minimum distance is 0.11 between P3 to P6. So our first cluster has been P3 to P6. Okay, now after making out this cluster, we have to update this matrix again. So how we will do it? Let's see. Okay, now while we are updating our cluster, this distance matrix, so how we are going to do it? Okay, so let's see that our first cluster is P3 P6. Okay, so we have to find out the distance of this P3 P6 to P1 P2 P4 P5. Okay, so let's say first data point is P1. So here you can see that this is P3 to P1. Okay, here we are finding out the distance among P3, P6 to P1. We are finding out the minimum distance. So our first pair would be P3, P1 and next pair would be P6, P1. So from this given matrix, we are finding out the distance among these data points. So P3 to P1, the distance is 0.22. Okay, and P6 to P1, it's 0.23. Okay, so what is minimum? You can see it's 0.22. So that's why we have to update our matrix by using this value. Okay, so let's move ahead and let's see. See, I have shown you one technique to find out the minimum distance of this P3, P6 pair to the first P1. Okay, then we have to find out this P3, P6 with the P2 also, and it is 0.15. Then we have to find out this P3, P6 with P4, and that is 0.15. And similarly, you will find out this pair with this P5, and the distance you got, that is 0.28. Please do practice. It's very easy to calculate these distances. Okay, let's move ahead and find out the next cluster. Okay, so here in this updated distance matrix, can you see that which one is having minimum distance now? So it's 0.14, which is lying between P5 and P2. So now my next cluster would be P2, P5. Okay, after getting this cluster, we have to update our proximity matrix again. Okay, so what we will do? We will find out this pair with P1, with P3, P6 and with P4. Okay, how? Let's move and see. Okay, now we are finding out the distance of P2, P5 to P1. So P2, P1. So my first pair would be P2, P1 and my second pair would be P5, P1. So you can clearly check from here my cluster is P2, P5. I have to find out the distance of P2, P1 and P5, P1. So P2 to P1 you can check from this matrix. So the distance between P2 to P1 is 0.23. Okay, and the distance between P5 to P1, it's 0.34. Okay, now we have to check the minimum distance among these points. So this is 0.23. So our updated value would be 0.23 between P2, P5 cluster and the P1 cluster. Okay, let's see the updated matrix. Similarly, we have to check this P2, P5 pair with the P3, P6 and with the P4 also. Okay, let's move and see. So see, we have got this updated distance matrix where we are having P2, P5 to P1 it's 0.23 and the P3, P6. The updated values are 0.22 which we calculated actually, but P3, P6 with the P4 it's 0.15 now. Okay, and this P3, P6 with the P2, P5 it's 0.15. Okay, now do practice and please solve these questions accordingly how we did in the last slide. Okay, now we will keep repeating the steps which we discussed. Okay, and finally now we have to find out the minimum distance again, because till now we have made only two clusters. One is P2, P5 and another is P3, P6, but we have not reached to one cluster. We have to reach to one cluster. Till then we will be repeating these all steps. Okay, now the minimum value is 0.15. So my next cluster would be P2, P5 and P3, P6. So it would be P2, P3, P2, P5, P3, P6. Okay, and now we have to find out the distance of P1 with the P3, P6, P2, P5 and with the P4 also. Okay, how we will do it? Let's see. Have a look. So we are finding out the distance of P2, P5 with the P1 and P3, P6 with the P1. Okay, so you can see the minimum distance would be 0.22. Okay, have a look on this updated matrix now. It's 0.22, 0, 0.37 and 0.15. So for now, minimum value would be 0.15. Okay, so after getting the value, minimum value 0.15, we got one value, that is, now we made one more cluster, that is we are left with only one, that is P2, P5, P3, P6, P4, and we are getting one minimum value, that is 0.22. So finally we are with one cluster now. Okay, that is P2, P5, P3, P6, P4, P1. So if we find out the minimum value now, it's 0.22 and the final cluster would be P1, P2, P5, P3, P6, P4. Let's see through the dendrogram now. Okay, so my first pair was P3, P6. My second pair was P2, P5. Then my third pair was this one, this P3, P6 and P2, P5. Okay, so you can see this branch, and then P4 was added in this cluster. So you can see this branch. This branch added P4 to P3, P6, P2, P5, and finally the last one data cluster, that is the data individual point, got added into this cluster. And finally our cluster was P3, P6, P2, P5, P4, P1. Okay, so I hope this video is clear to you all how this single linkage actually works. Okay, any problem or any doubt, you can comment. Thank you so much. I hope you liked this video. If you did, then please do like, share and subscribe. Thank you so much.